Good afternoon, respected teacher and their classmates. Assalamu alaikum. My name is Asif Ahmed, the student of Department of CSE, and my ID is 2352158 Today, I am honored to present my final term OBE assignment for the course Digital Logic Circuit under the guidance of respected teacher Nafiz Ahmed Chisti sir. My topic of my project is digital parking control system. Now the main problem addressed in the project is how to monitor and manage the parking garage that can host up to 12 cars. The number of the cars from the digits of my student ID, where is A plus G plus is, that means 2 plus 8 plus 2 equal to 12. The system should accept a maximum capacity through a keypad and then continuously monitor the number of vehicles entering and exiting from the garage using the sensor placed at the entry and the exit points. So at first, I have designed a 4-bit encoder, and then we have made a keypad by using the encoder circuit for a 12-bit. Uh, and then I have simply made the equations for y3, y2, y1, and y0. And now I have made the logical circuit by using these SOP equations. For y3, I have just simply used a OR gate for y8 to y12, y8, 9, 10, and 10, 11, and 12 is just added with the OR gate. Now I have used a shift register in SIPO mode for storing the encoder values for four shift registers. And now I have used four-bit comparator. It checks if the current count of the cards is equal to the max capacity. Then I have used two triple five timer. The first one is in astable mode, and the second one is in a monostable mode. The astable triple five timer generates the clock cycle, and this clock cycle sends to the monostable timer, and the monostable timer gives the output for blinking or space available or space full. Then we have used synchronous 4-bit D flip flops. I have focused designing the digital counter using D flip flops for this system. A 4-bit counter is sufficient because we have need to count up to 12, up to 12, which is within the range of 4-bit binary counter. The deep flip-flops are ideal for such counters because they can store binary values and change state at each clock pulse. I have connected the flip-flops in a synchronous configuration where a flip-flops share a common clock signal, which ensures the reliable counting with a few glitches. Now I have made the block diagram and the flowchart. The flowchart shows the entry and exit systems, and it counts the when it is A equal to B or A less than B. A equal to B means the space available equal to the maximum car numbers. Then it displays the full, and then the A less than B means there is space available. Then come to the question number two, and we have asked to calculate the values of R1 and R2, and we have to put the values of R1 and R2 into the triple five timer circuit design, and by the formula, or we have got P and frequency D equal to a duty cycle, And from the formula, we have calculated the value of R1 and R2. We also get the TH and TL, and by sum TH and TL, we get the total timing period. And we have calculated the R1 and R2, and we have put these R1 and R2 values into the circuit. The R1 value we get 388.45 and R2 286.87 ohm. And we have also used the capacitor value 250 microfarad. And we have also mentioned there the additional components needed to solve this problem. We have used the D flip flops for stores and counts the entry and exit, and counter is used for count total car. Comparator is used for check garage full or not, and we have used the logic gate to control 555 timer. Now we have used another 555 timer, which is a stable mode, to display full. Now come to the question number 3. Here we have to design a FSM for the circuit. And for this blinking control of space available message, I have designed a finite state machine and FSM. The purpose of the FSM is to alternate the display between on and off states according to the instruction. The output should remain on for TS millisecond and off for TL milliseconds. However, for this task, both TH and TL are limited to a maximum 4 milliseconds, and they are each state is available for 1 millisecond. And I have simply made the state table from the state diagram, and from the state table, I have calculated the A and B values. For simply A, we have to see uh, we have to see where is one available. Here one is available, so we have to see the present state. Present state PS2, 1, and 0. All are 0. That's why we have to use PS2 bar, PS1 bar, and PS0 bar. It is simply the formula, and we have same according to the same rules. We have calculated the A and B, the soft expressions, and we have calculated the Verilog code. We have written Verilog code by seeing these A and B SOPs, and we have used there these simple Verilog expressions to write the Verilog code. Now, at last, there is some limitations for this assignment. And while the system works well for a small garage, it does not have does have some limitations. First, for the 4-bit counter, it restricts us to a maximum of 15 cards, which is not enough for digital parking areas, which is not enough for larger parking areas. Secondly, the timer 555 timer has no enable pin, so we cannot pause or restart its output directly through logic control. Thirdly, the display is limited to basic messages on 7-segment displays. To improve the system, we can use a 8-bit counter, which will allow counting up to 255 vehicles. And we could also replace a 555 timer with a multi-controller multi-controller, which would offer better timing control and more features. And these modifications will help us to build a better traffic control system. And thank you everyone for hearing me.